All right, I'll just let that go a minute. Oh, so the challenge we have with recursion is basically recursion is solving a problem in terms of itself. And usually it's kind of an inductive process. There's kind of a base case that is pretty easy to solve. And then more of like an almost induction case or generalization. You can use the simpler cases. It works in terms of simpler cases. So if we're always calling with a smaller argument or something like that, then we know we're going to make progress because eventually we bottom out at 0 or 1 or whatever the base case is. And so the example, well, let's just say test tower. I'll just start going while it's building. I made the mistake of trying to upgrade at 10 o'clock this morning, and I finished at about 12:55. So we'll see. Hopefully things are all working. All right. So I'm going to have the notion that there's a tower class, and you're going to ask it to move to solve a certain size puzzle. And we'll just take the base case first. So what do I want the output to be? That's kind of a challenge here. So one thing is I could just list out the moves that we made. That would be one level. Another level might be actually moving things around on the stack and so on like that. Well, let's deal with the logging aspect first. Okay, so hey Code Wrangler. So what we're going to do is we're going to say the output of this thing is a string output, and I'm going to make assertions about what the output is. Okay, and so the simplest one. Let's take a trivial stack. Okay, I'm going to assert equals. Whoops. Wake up. Come on. Well, I'm going to say if you have a tower of 0 moves or a 0 peg, 0 disks, then you shouldn't really have anything in your output. There's no work to do to move that tower over. All right. There we go. So my log, I don't know. You seem to get this the option of doing either way with this equality test. So I'm going to say my tower.log should be equal to nothing if I move. And I'm going to say tower.move 0. And then we have to deal with what are we doing? I think what we're saying is move how many disks, and then we want to imagine there being 3 pegs. I don't know. I'm inclined to put, well, it's like I don't mind being ugly at first if I get it better looking, but one way would be to say peg 0, move 0 from peg 0 to peg 2. And just assume the pegs are numbered 0, 1, 2 going across. That's probably okay. Let's make this. I'm just going to put it here for now. We got enough going on. Are we still launching? Yes. All right, so we'll just create a class right here, get this thing to compile, and to do that we need a function move, and it's got a number of disks is an int, and I don't know how abstract to make it, but let's assume that From is an int and to is an int, and I hope those aren't reserved words. All right. And then I've also assumed a log, which is a string, and it's a variable of type string, and it equals random junk for now. Okay, so let's see. Hopefully he's waking up. All right, cool. Okay, so anyway, we're compiling. I guess I'll just let that warm up and finish building. I think they've gotten slower in the last week, but who knows? All right, well, let's think through our example here. So we're doing this base case 0. We basically expect I can just turn the string into an empty string and we'll pass. Okay, let's peek ahead. I don't know. I just can't stand sitting around like this. This is tower with no disks. And let's test a tower. Yep. We're going to go. False alarm. Let's test a tower with well, let's try one disk. We'll work towards it a little slowly. And okay, is it running? Yeah. I don't think it is yet because I think they default to a hello world, right? Yeah, text hello world with some padding. There it is. Okay. 10 minutes to get that running seems awfully high. Okay, so let's run our tests. We left out a brace. All right. So with recursive problems, the tests are usually there's usually just some level of tests that are base tests, kind of the base case. And then there's some level of test that's higher up that's going to call it. Okay, I'm paying people to pound on my wall today. I thought they were going to be done yesterday, and it looks like it might be tomorrow. So I may get very good at turning off my mic and see what happens. Okay, so what we'll do is we'll get this one working, get the next test going. Apparently that's going to be slow too. This should fail, of course. So we'll generalize that slightly here. All right, let's see if we can get that recursion in. This should be the whole formula for moving two disks, and we'll see what happens. All right, and here's the real insight. If I want to move all these disks over, if I move all but the last one over out of the way, then I can move the last one from where it started to where it's going, and move the others back. So it's sort of a two recursive call kind of thing. And this is my, I don't know if there's a better way to do this, but if I want to get the leftover disk from 0, 1, or 2, I take up their sum, subtract off the 2, and the one that's left is the right one. Now I'm not sure. I may need to add new lines in here, or if I'm okay like this. We'll see. I may be going the wrong way here. Okay, I guess that's just that last new line on there. Okay. Dreading the pounding here, but at any rate, I think what we've done though is we've got this kind of minimal version of this thing. It's doing the right stuff. I think we've got some work to do, um, but I think we're okay. And I'm just gonna do a little kind of dummy test. Um, let's just write one that's a bit bigger. Let's just do like 5. All right, and I'm just expecting something that's well, basically it's taking 2 to the n minus 1 or 2 to the n minus 1. So a 2 disk tower takes 2 to the 2 minus 1. 2 squared minus 1 is 3. This one I expect to be 31 moves, so I don't expect it to be these 31 moves. They'll show up in there somewhere, but um, yeah, so I expect a long list. Yeah. And if you go through this, you'll see patterns in here that you can take advantage of as to if you wanted to do a non-recursive iterative solution. Okay, but what we're going to do is some refactoring. That was just kind of informational for me. I want to refactor it enough that we can um, start visualizing something. Sorry. And I'm going to add some instrumentation so we can at least get some sort of view of what's going on. And I think the interesting one to do is I'm going to just count the number of calls coming into this top level method. All right, so let's do that. And to make it visible, I'm going to make it observable, and then my content view can look at it. So let's see what we can do there. I'll stop programming Java someday, I'm sure. Now you should make your prediction how many calls we're going to see. I have a number in mind. We'll find out. We'll look at reducing that later. Basically, because we call zero all the time, every time we get down to one, we'd make another two calls down to zero. So that's why it's surprisingly high. But I'm making this a publishable, well, observable object with a published field, and that means I can pass it in and use it, or create it and use it in my content views. So I'm not going to try and test that. I'm just going to try and add it in. Just sort of my first visualization. See if we get anywhere. I'm probably gonna have to go look up stuff. I'm sorry. It's a constant state for me. But I'm trying to create a tower object and display its count and a button. Okay, that sort of looks good. Yeah. All right. Now the thing we don't have is it's well, it runs so fast you didn't see it do anything. Okay. Oh, and it didn't clear. Okay. Sleep for a time interval. It's like a unit. Now, I expect our test to just pass. 0 times 1,000 is sleep of 0, so hopefully that does okay. Well, there's some delay, but we're not updating while we go, so I don't know if I've messed up the timing too much. We'll see. All right, I don't have the patience for how long that must be. If that's really seconds, then we're still calling 10 or 100 seconds between each one. That's just crazy. Let's go back to the Mac one. Um, it's like I don't have a just simple sleep. That's really annoying. You sleep takes millions of a second. He wants 4 seconds. That's a 4. Okay. And that takes. hmm. I'll just manually set it and hope for the best here. See if it goes. Really, I want to see my counter update once in a while, not just give me the value at the end. I was glad to have it give me the value at the end. It means that something was updating, but see how this does. 1001, 1002, 1003. Well, that's going to be a minute to get our answer, and we're not seeing the count update. So I've done something wrong. It, I missed what, but I don't think it updated at all. I'm trying for a tenth of a second. Yeah, I'm not sure what I have to do to get ongoing updates on this thing. I'm well. I don't know. I may want to move forward. It's yeah. I may have to do a little more research in there. I get mixed up with the bindings, but bindings I think you only need if you want a two-way thing. But this, because it's published, I thought it would every time this changed would trigger a refresh. That this would know it's observing this and need to get to it. Um, all right, so we've been going a while, and I'm sorry again for the noise, but let's take a 2 or 3 minute break. Welcome back. I just did a quick search. The one I found a decent example. This hacking with Swift site saves me all the time. Um, the difference here is they're using at state object, which is a little newer thing. Um, but let me try that instead. And I think the rule is the topmost object controlled by this view should be a state object, and then if I called subviews or internal helper views, I would pass this in, and they would be observed object. So they're sort of the dependent reference. So let's try this way. I may give up and go on to something else, I guess, at some point. Um, and okay, no, we're not seeing any action there. And I guess if I'm right, yeah, 6.3 seconds. Oh. Um, Now there are cases where you have to notify, but it's like it's all supposed to be so automatic. Um, that's the confusing thing for me. Oh, did I mess this up again? Like in my tower, maybe I need to update some listener or something there, but I don't think I'm supposed to have to for simple types like this. Okay. Um, all right. So I warned you I'm going to kind of bounce around because I don't have a particular order of things. I just wanted to do a little progress on the visualization side, and I can visualize the end result, but not the beginning. But let's go. Let's do two things. Let's see. Normally, I maintain a to-do list. So, recursive solution, we've got that. Um, Visualization, we created some view of the counter and some notion of delay. Okay, but we haven't done much else. This was just the basic recursive solution. All right, so I'm going to go back to the recursion. And what I want to do is revise this. I don't really care about 0. Saying we move 0 disks is pretty boring. So what I'd like to do is modify this thing, take it up one level to a disk. It's got to have one disk to start with. And let me see what I can do with that. So I'm going to say I don't care about this anymore. And I don't care about this because it's just a demo. All right, so I'm going to have the 1 disk and the 2 disks. All right, and the thing I want to do then, it's kind of like, I can almost think of it as inlining. I want to say if I had the case of 1 disk, all right, it would go through and say the number of disks is greater than 0. Yes, move 0 disks from from here to there, move 1 disk from to 2, and then move 0 disks from here to there. Well, I would like to inline this in effect, and I'm gonna change things around. I'm not gonna worry about the 0, but I'm going to say if the number of disks is 1, then do something else, do something else. And the else is the original. Okay, and if it's 1, I'm just going to move it. So in effect, I could do it slowly like this. All right, so I'm saying if I did it like this, then you have the case for 1, we're going to do this, and otherwise we do that. They're the same case, but now I'm going to say if the number of disks is 1, moving this calls move 0, 1 minus 1, something, and we know that just returns, so I don't need this line. And same argument here. If its number of disks is 1, then this is 0, and I don't need this line. All right. Now this is a path that can get you tangled up in the recursion. And if you sort of pick the base case at the wrong level, then you definitely see a difference, and you can tell it's getting tangled up. But my intent is this should just pass. The only difference will be the number of calls is going to be less. So we'll uncomment that other one in a moment and check that it drops down to 31 instead of 63. Where's my tests? All right, so it passed. That's a good sign. Let's uncomment this. And I'm expecting 31. I know there's a way to get the console on here, but yeah. All right, there's 31. So we've cut our number of moves in half by taking the simple case of 1, and I still have this check up here, but in reality nobody will ever call it. And I've got a choice if I want to leave that in. That's fine. It doesn't hurt anything. We can leave this test. Because we still check for that 0, so it's going to bug out before anything happens. All right, so this is something of an optimization, optimized to handle level 1 without calling down to handling 0. Okay, so I think that's all right. Let me check this in. I think I set things up for that. And we'll take that out. I'm sorry, I keep making sure my mic is on and realize. Okay, now let's do this one. Well, we know if it's 2 to the n, I mean, it runs so quick, like 10 is nothing. Let's run 100 and just see what happens. That may be a little ambitious. 2 to the 100th is a lot of stuff. Okay, that is too ambitious. Let's try 30, right? Something like a million. Okay, let me stop that and try again. So 1 million calls, is that going to be noticeable? I mean, it's a multi-gigahertz processor, right? Each call's got to push stuff on the stack. My stack may blow out. I don't know. Although I guess, yeah, I don't know. The depth should only be kind of proportional to the number of items. Okay, that's running. All right. Well, we'll let that go. And I don't know if I can figure out what's going on with this. So here's the observable object. Publishes a field. The outer view has a state object that holds the field. It can report on it, and it doesn't need a binding because it's not trying to change it. It's just reporting on it. But it can also call the interview, and this says use the field as a parameter. Oh my god. Okay, I'm gonna take a break while I try and move somewhere and see if that's any manageable place I can find that's a little quiet. So this is started. It's still running even with our delay there. Okay, so yeah, I mean, you hear the story, the legend that gets attached to this puzzle, that, somewhere there's 100 tower or 100 peg discs on the peg, and they can move one every day or something. And when they're done, the universe will end. But 2 to the 100th seconds is a lot of seconds. Okay, so all right, let's see what we can figure out. So I appear to be showing the count. I don't know. The other place I want to go was this notion of memoization, and maybe that's what we'll do is just repeat this work, but add this notion of memoization. So I'm going to copy this function, and I'll just call it old move or original move. Okay. And the notion with memoization is to say, we're doing stuff and it all sounds very familiar. We make these calls, and we, at some point we're trying to move 5 pegs from peg 0 to peg 1, or from peg 0 to 2, and that move is going to repeat because we have the deeper pegs. We're going to have to move it multiple times. So the memoization idea says, if we're doing this exponential number of things, 2 to the nth, then what if we remember some of them, and when we get back around to doing them, we can just kind of play it back. All right, and so I think what that means we want to do, well, I guess, like, what would it mean to say move returns the string that's the description? Okay, so let's get our to-do. So the memoization idea, we have to put in some sort of cache. All right, and because if we've seen a call move 5 pegs from 0 to 2, 5 disks from 0 to 2, we will have seen that before and presumably can use what we already have. And so I guess we're going to cache strings. Okay. And I'd like to capture the number of things that go through the cache. All right, so let's return the string. Is there a good way to do this? Yeah, let's return the string. Okay, so you should be returning the string of moves to me at the end of each one. Oops. So return nothing, and let's change our assertions. So let's do this, result equal tower.move, and then this should be result. Okay. It hasn't caught up to us yet, but we'll do the same thing here. And here. All right, and so I'm going to actually kind of start over in a sense. I'm going to add a return here. And a return here. All my paths that return are going to do something. I guess I'll do one and then more at one. All right, so result of call from move one. Yes, that's true. Okay. And so our tests, we'll take this one out. Well, yeah, that's okay. Take that out. And I will do a run. I expect the first case to pass because 0, I returned an empty string. Okay, now let's make this case work. Tower. And we're going to get I'm still returning the log just because I don't know if I'm going to use that in my visualization, but we'll definitely return this, and I think it should pass one more test. Oh. Return string. And this should be return that. I expect the one disk case to pass as well now. All right, good. And now this case. So this one is the multi-disk one. Okay, so we're going to catch that. We're going to append this, and we're going to append this, and return a result. All three should pass. Yeah. Okay. So the new phase, we're not looking at log really. Let's make our assertions not use log. Yeah. This one, yeah, we don't care about this test. And I think I'll even just make that explicit that we're not really doing any assertions in this test. Okay. So now we have a result that we can say the result of our function is, and it's the string formula of how to move the disks around. Okay, so given that works, we're just going to say, whoops. Oh, that's the original function. Maybe I'll just comment it. We may want to go back to it. That's no reason I'm keeping it. Okay. Let's commit this. So make tower return a string telling how to move the disks. All right, now we can talk about memoizing. So the deal is, if I call this thing, I'd like to have some sort of cache, and I don't know, it's like, how much do I want to test drive this into place or just rely on it? It's kind of funny because from the outside you can't see it, right? That's kind of the point. It's always the case with these caches. But it really is, what are we caching? We're saying, if I say move number of disks from 2, it's really this triple that's being cached. All right, let's just try and do it. And the cache is going to store strings. So the cache is, and can I say int to string? Starts out empty. Okay. Int does not conform to hashable. Okay. Well, the thing is, it's so, once again, okay. Oh, I'm confusing myself. All right, here's tower. Well, if I said struct arguments, number of int from of int to int. I think if I say hashable, this thing might just generate it for me. Is that going to be true? Okay. I mean, yeah, it still passes tests, right? I don't know. All right, so we have this cache, and I'm just gonna put it in, right? If let previous result equal cache sub arguments from to int number of disks from is from, to is 2. Okay. So I'm saying if you look in the cache and it's already there, then just return this previous result. Okay, and oh, our run actually finished. Yeah, 0.5 seconds, right. I guess we don't have that test in there at this point. Okay. Well, even with 5, let's do a run with. Well, let's see if the tests pass. They should, because it will never. Nothing goes in the cache, right? So. There's no harm done. All right, now. Okay, so you can see I say if there's something in the cache, but nobody else references cache, right? So it would be nice if we could store the cache here. If the number of disks is more than 1, well, I could do it on either one, but let's do it here because it's the bigger opportunity. So we'll say cache of arguments, number is number of disks, from is from, and to is to, equals result. And run the tests. Okay, so the tests all passed. Now let's undo our X, and let's print number of calls, right? Calls is tower.number of calls. All right, now before, recall this started out 63, we cut it in half by getting rid of the zeros. Now we're going to see what, oh, stop. Let's try it with 5. Let's try that again. All right, so we're going to see, does it really need 31 calls now? Or how much have we gotten rid of? Now the deal with this is, right, this is a space for time trade, and you know, the bigger thing that we find we've already done, the better off we are. Okay, so it passed. I don't know how I can lock that debug view in. Number of calls 19. Okay, so that's substantially fewer. Let's try. Well, 10's 1,024. So this should be 1,024 minus 1, 1,023. And let's see how many calls we actually make. Okay, so 2 to the 10th is pausing a little. Okay, but yeah, so what we've done, we've cut it down from 1,000 to just under 50. Factor of 20. All right, let's move up another factor. Okay, so 2 to the 15th, 32768 minus 1, 32767. Nice max int for a 16-bit int in C, right? And let's see what happens. Now we'd expect, you know, a lot fewer calls than 32767. Still a good pause. I mean, we're doing some work, and we're doing a fair bit of string appending. All right, how many? 79. All right, so we increase the number of moves by a factor of 2 to the 5th, 32. Increase the number of calls by only 24, 20, 30, 30. Okay. That's not a very big increase, is it? Well, normally we'd expect the calls to be proportional. Yeah, this is more proportional to the size of the problem, not the size of the full solution. It's still got a big solution string. Okay, and let's try 20 just to kind of narrow it in. So 2 to the 20th is about 1,000,000. 2 to the 10th is 1,024, so 2 to the 20th is about 1,000,000. All right, and I don't know how many, I meant to read how many seconds that was just now, but it's a noticeable delay, right? I mean, that's no doubt. Okay, 1424. Okay, what did it say? 11 seconds. So that's moving 1,000,000 disks in principle, or the formula for 1,000,000 disks, in 11 seconds. What did we get out of that? 109. Okay, so we added another 30. Oh, so we noticed 19, added 30 to get 49, added 30 to get 79, added 30 to get 109. So I'm going to predict if I do 25, I'm adding another 30. Okay. And I guess if that was 11 seconds, this is adding 32 times as much. I don't think it's going to be 32 times 11 seconds, though. That'd be about 4 minutes, maybe 5. But this is, yeah, 139. So yeah, it's adding a factor of 30. Now we could add a cache here as well. Let's do that and see what happens. I'm going to cache the solo ones. Cache sub, I guess all this. Equals results. All right, we'll run this. Okay, so we had 139 was our result, and didn't look how many seconds. Okay, 139 still. So is this not really mattering? Let's back it back down to 20. Again, 20 is about 1 million moves. Seconds, 109. Okay, so that doesn't appear to be making any difference. I'm a touch surprised, because I thought every peg moving from, well, no, I guess the only possibilities are 0 to 1, 0 to 2, or 1 to 2, right? So there's only three things, and after the first time you grabbed one of them with a 2-level thing, you would have covered all those. So let's take this out if it's not doing anything. Actually, I can probably undo my way out of that still. Okay. And I'll put this number back down to like 10. Okay, so memoization, we've added a data structure to hold the results we accumulate on the way. Because each result with recursion, each result is built from these smaller results. You know, we've cut out lots and lots and lots of duplication of answers. You know, there's only so many ways you can say move from 0 to 1, move from 0 to 2, and move from 1 to 2, right? All our moves come up looking like that. Okay, so that's cool. 5 seconds. All right, and then 5 is where we're going to stay. 4 to 9 calls. All right, and let's give that one more run. Okay, and so what we've done is added a cache to get memoization of our results. Now, sometimes your memoization can be a lot cheaper to get. I'm thinking of like Fibonacci, where if you wrote recursively, you know, calculating 13 is 5 plus 8, and 8 is really 5 plus 3, and 3 is really 1 plus 2, and 1, you know, 2 is really 1 plus 1. You know, you do that multiple times for every branch, but you can imagine storing Fibonacci, the first Fibonacci, the second Fibonacci, the third Fibonacci in an array, and then you just consult back to the previous array. With this one, we can't do that because we have the 3 arguments all vary, but there aren't that many possibilities, so it's not bad. And maybe you could break it up, and maybe you could have an array for 0 to 2, 1 to 2, and 0 to 1, or something like that. All right. So, I mean, that's all I hope to get out of the memoization. Let's see. I want to save the recursion for tomorrow. So let's put this down here. All right, so I think what I'm going to do for the rest of the time today, which is about half an hour, is try and figure out how to get my screen to update during the visualization side of things. Like, yeah, so this, usually I kind of have a stack going up on my to-do list and a list going down from where it says done here. And my stack, I kind of want to figure out why intermediate values aren't showing. Okay, and I think that'll be enough challenge there. So so where we are, I'll say I'm just going to work on trying to figure out how come my values don't update. I'll pick up with recursion tomorrow. Recursion elimination as a refactoring, and I won't do anything today other than debugging. So if if you can't stand to watch that, good time to leave. I will take a couple-minute break, just grab a drink or whatever, and be back and figure out what's going on with my updates. I'll at least learn something about Swift UI. I know with the sort tables program I did, I know we had to do some notifications, but I thought that was more because we were using compound types. But um, I have been through this path before, so hopefully it looks familiar when I try and solve it now. See you in 2 minutes. All right, I'm in the mode where I can't catch a break today, so we're getting a pretty good solid thunderstorm right now. I hope the noise isn't too annoying, but it's got to be better than the hammering. I assume they're gonna stop hammering in the rain. All right. So why aren't intermediate values showing? All right, let's do some searching. Whoops. Um, yep, good to see you, Code Wrangler. Thanks for joining. Okay, so and this seems to say I can update it from this side. I've got the object as an observed object. I can modify it, and the view in the content view will update. But yeah, okay. Observed object is updated, but the view that observed is not. Yeah, this is me all over the place. Random numbers and a button. It picks one. Okay. Observed object is the number line, which is observable. Well, they don't have published on there. That's a little suspicious. Visible account. Okay. With observed object, everything's fine. Okay, take your code away and okay, we used published. That's good. Once in a while, we need to do the send kind of thing. I don't know where he did that. Oh, here. Object will change dot send. Yeah, and that's sort of the point of this published thing. Okay. Need a dynamic for each. Replacing observed object with state object work. Has no connection. Okay. Yes. I don't see what he did. Okay. Child view. Yeah, this case I think is different. So he's got a state. Right. He doesn't want to use state on the child view. Okay, let's see Swift UI progress bar example. Like, I just want the simplest kind of thing. Start progress. Now he's binding to a simple variable type. Yeah, here's the state with the variable. He passes in the dollar, which is the binding form. Yeah, I just don't think that's the same issue. Although, maybe, can I do a binding form? Is that going to work? Or is it on this? Tower. Calls. No. Okay. I mean, the binding normally gets you into a two-way link to the thing being bound, but we're not changing it here. The deal I'm worried about is we're changing it in move, and maybe we need to do that send that was in that first example. Let's see, that was this one. And I think he did what I think we would do. So it's basically saying object will change dot send. I thought that's the point of the publish. Honestly. Let's go back and add it in. Now I think, well, let's just run it. I'm not sure that gets us there though. It happens before the change. Nope. Do not use observed object to create instances of your object. Use state object instead. Okay. And this is only observed because it's a parameter passed in from a state object. We have the state object. Can I split my screen? Okay, so maybe I'm back to progress bar kind of things. Let's see if that example has anything good. See, they got the manual increment. That's just not what I'm after. indicate progress. Add animation to create smooth progression. That's kind of nice. Self.progress. I mean, progress is going to be just a simple field. Finding progress of a float. Yeah, so the progress that gets passed in is a floating point number. Is sort of a simple piece. And keeping track of simple pieces of value objects like float that's using the binding and the state stuff. Okay, now here they're adding their increment button. They're just updating the value and everything's okay. I don't know if that's because they're on the content view, they can do that, and it's just a simple value. I want to say when something's received, update value as code runs. No, that's not what we want. Updating the state from inside the body. Oops, sorry. Binded doesn't sound right. Binding, okay. Instead of did set, use change up. Well, we can try this sort of thing. I think I'm going to do that. cannot convert value of type int to expected type nothing. Well, I can make a VStack here. Let's try this thing again. One change on that thing. Type cannot conform to equatable. Alright, let's try this. Swift UI observed object not responding. Yeah, so the idea is this thing of value versus not value objects. Right, this any cancelable stuff is definitely something I was doing in the other application. Basically, each one sends object will change, and then add this to the cancelables. Ugh. I just don't feel like I should have to go through that for a field. I don't feel like I should have to change it to a state value object kind of thing either. I've got the state object tower. Can I make a binding? Now it has the binding. Is that really legit? I don't think so. I don't think that's gonna work. Yeah. So I guess where I'm leaving off here, the problem I'm seeing is when I update that number of calls, it appears that nobody is listening, and they only do their stuff after this button runs. So like I don't know. I'm just going to try and force something in. Dot object will change. Dot send. I'm going to set it to 10. And it should start 0. It should turn to 10. Hopefully it displays 10 and then it displays 19. I got a feeling it's just going to display 0 and then 19. Yeah. Yeah, 29, right. Will send does not force a redraw. I'm not sure what to even search for. Async change. That's probably the word I should be using. Okay, this sounds exactly like what I'm complaining about. We have the observed object. It's got a product view model product. And we want to display it. Okay. It's got the published field on an observable object. They're doing the sync notification that seems like the publish should be doing, but okay. Wrapping self.product equals product inside dispatch queue main.async. Yeah, it's hard to debug declarative frameworks. That is definitely a true thing. I think we need to separate every variable that controls your UI. Combine has a memory leak. Yuck. But this is something on the right track. Update async. All right. Well, I'm not seeing anything obvious. Okay. Unfortunately, this thing doesn't link to the thing either. All right. So we'll pick up tomorrow. I'm hoping it'll be a little quieter, and we will do attempt to do a recursion elimination refactoring. And if there's time, I'll pick back up on this UI problem because I've got to work it out if I'm going to do any algorithm visualization for other stuff. So a few patterns I've got in mind will help on that. But most of tomorrow I expect to be refactoring. So thank you for joining me. I hope you can join me in the future. And I will see you then, 9 to 11:30 a.m. Eastern Time. Bye-bye.